Fantastic. Thank you, Larry, for the introduction, and thank you for inviting me to be part of this workshop. It's my first time in Montana, and it's really nice to be here. Also, it's delighted to be part of this vision of the NRP, which I do believe is going to be a big part of our future cyber infrastructure ecosystem. So today is exactly 6 months since I joined OAC and NSF, and I've been spending a lot of time trying to understand the community, what the needs are. It's a very diverse, very broad community with very, well, huge needs, but very diverse needs. And while NSF's resources are constrained and cannot meet all these needs, I think they're non-trivial and can have an impact. And I think we have to find out where exactly NSF's investments can have an impact. The other thing I'm realizing is that we are in a time of change, and a change in the nature of applications, change in the technology landscape, change in what industry and campuses are doing. And the only way that we can meet all these needs and have an impact if we can come together with industry, with campuses, and leverage those investments and be able to create a more collective, inclusive cyber infrastructure ecosystem. Many of you have heard me speak many times over the past few months, and so I'm hoping there's something new in here that you haven't already heard. I have more slides than I should have for a 45-minute talk, so I'll go through some of these things quickly, but I wanted to leave them here because I think they tell the whole story. So let me get started. That's an outline of my talk. I think this is redundant. I use this to remind all of us and myself what NSF's mission is and how important cyber infrastructure is to all the three dimensions of that mission. A quick note about the budget. You have seen this before again. We have the 2018 appropriated budget is still at this point. The good news, and that's the reason I put this up, is that despite all this, the dance we went through, it was a 4% increase, right? And this represents the second largest increase NSF research budget has in the last 15 years, right? If this is indication of the future, and I am naive enough to be optimistic, this is good news, right? We also have a presidential budget request for 19, and this is flat with respect to 17 at this point. I'd like to call out two things here. One is that the size budget, and that's where OAC's budget sits, is down about 1%. But what has happened instead is that NSF defined the big ideas, and I'll talk a little more about them in the next couple of slides, right? And they have exclusively allocated money for each of these big ideas. There are 6 research ideas and 4 process ideas, and each of the research ideas have $30 million in the budget for those big ideas, and the expectation is that would continue in subsequent budget. They also have a concept of a convergence accelerator, and I'll tell you what that is. But there are 2 convergence accelerators defined. HDR, which is harnessing the data revolution, which is one of the big ideas, and human technology frontiers and workforce of the future, and each of these have a $30 million budget item in there, right? So in terms of big ideas, here's a quick snapshot. These are bold questions that will drive NSF's long-term research ideas put forth by the director, Franz Cordova. There are a bunch of different ideas here, and you can read them on the slide. Harnessing the data revolution, work at the human technology frontier, windows in the universe, multi-messenger astrophysics, navigating the new Arctic, understanding rules of life, and quantum leap. And at least 2 of these Our NSF and OAC are a big part of it. HDR, OAC is actually leading that activity. These are all NSF-wide activities, by the way. So what it means is that the budget comes into a directorate, but it is worked on collectively by all the directorates involved, right? And so HDR is being led by SAIS and OAC, and I'm actually chairing the committee for that. And the second one where SAIS is playing a big role is Quantum Leap, right? So those are places. But SAIS is part of all these big ideas. In addition to that, there are 4 process ideas. And I'll point out the mid-scale research infrastructure, which I think this community can play a huge role in. And that's sitting part of the Office of Integrative Activities and Office of Director. And the other point I'd like to make is that, cyber infrastructure cuts across all aspects of these big ideas, and there are tremendous opportunities for this community. I want a quick note about convergence accelerators. This is a new concept that's evolving. And the idea here is to have time-limited multidisciplinary projects, right, that can bring communities together and bring industry and campuses all them together to address these specific problems that can have a huge impact. They can sort of accelerate the impact of the research investments that are being made, right? So these are the mechanisms for this are still evolving, but you can think about more. And when I try to understand it, I use the word DARPA-like, but that's sort of the vision behind this, right? To really bring communities together so that you can accelerate the impact of a lot of the research that's going on. And again, these are cutting across all the directorates. So the resources for this do not sit in any directorate. These are sitting at the Office of Integrative Activities, and they necessarily cut across all these different directorates. So a quick note, a few days back, we had a memorandum come out which highlighted the administrative's priorities in research and development activities, and I'd highlight a couple of things out here, right? So the first thing is that strategic computing is still a big part of this, right? But what this means has expanded, and we've worked closely with the OSTP on this, right? So I'll highlight 2 things here. One is they define it from the edge devices to high-performance computing, right? And now bringing the network and the campus and the other resources as part of strategic computing has become a big part of it. And they talk about low-power, high-performance devices to the high-performance computing devices and bringing them together as part of an ecosystem, right? So this broadens what strategic computing means to administration and also tries to expand it to include more than the big machines, right? And I think that's a very, very good thing. I don't have a lot to say on this slide except the thing on the red. I think you are more familiar with many of the people on the slide than I am. I have been working together with them for a long time. But I'd like to highlight that there are always opportunities at NSF broadly and OAC, and we always are looking for good people. And it's a very satisfying role. This is my 2nd round at NSF. In terms of size and OAC, what we do, so OAC is an office, and what this means is that it sits at the intersection of all the directorates. It necessarily interacts with all the directorates and offices in NSF and tries to address the cyber infrastructure needs and across all of science and engineering, right? So it fosters a cyber infrastructure ecosystem to transform computational and data-intensive research across all of science and engineering. So we work very closely with all the directorates, and we address not only the research cyber infrastructure, but also the cyber infrastructure research that's needed to address many of the changing needs and disruptive technologies that we are looking at. And our investments span a lot of things that you see at the bottom of the slide, from computing resources, data infrastructure, networking, software stacks, cloud services, and most importantly, the people and organizations that are critical to this, right? And the way we do this is through our programs. We have a bunch of programs which are binned in clusters more traditionally. computing, data, software, networking and security, and learning and workforce development, which is a growing part of our portfolio. There are solicitations that come out in each of these clusters, and more you're seeing a convergence because that is making sense. For example, recently data and software came together in the CSSI solicitation. I'd like to highlight one thing which is that many people do not know about, which is the CSER program that's listed in the bottom. This is a program rather than a solicitation, and what this means is that there is no deadline. Whenever you have a great idea, you send in an email to the program officer with a one-pager, and then you can submit a proposal. And this is good because if there are opportunities that come up or you just have a great idea, you don't have to wait for the next solicitation, right? You can submit it and get resources to pursue that idea, right? So you can find more about that on our website. And finally, public access is something that is NSF-wide. It's very close to very important to the director, and it's something that OAC is leading, and you'll see more activities in this space as well. So I viewed this slide, and you've seen this before, but the message out here is to these investments, right? When they come together, great things happen, right? All our investments over time. What you're seeing out here is a slide showing the discovery of the gravitational waves from the LIGO Observatory, and a whole bunch of CI, Cyberinfrastructure, OAC investments that came together to make that happen, right? And so these investments, your work is important, and collectively it's having a tremendous impact. This is one example. There are many more like this, and it's an important part of what we do. So I wanted to, with this brief introduction of OAC and where we are, I wanted to talk about some of the emerging science technology landscapes that have sort of something I'm discovering and that are informing our priorities as we move forward. So you're quickly realizing, and this workshop and the events that preceded it are a good example of this, right? There's a huge change in the science and engineering landscape. We have large simulations that are getting only larger, large application and computationally and data-intensive applications, but changing in their nature. They are increasingly multi-scale. There are more workflows that are combining different physics together and analytics and data processing as part of it. More and more we are seeing people looking at data-driven models as a lot of these instruments come online, right? How do we derive models using machine learning techniques and be able to say something about the models that come out? How do we use data as part of this modeling and simulation and scientific processes, right? A lot of the large facilities that NSF has invested in and other people have invested in are coming online, and they're producing a lot of data, right? And a lot of these data tends to be disconnected from our resources, from the users, and from each other. And how do we combine them together, right? And they're becoming a big part of the science, and that creates a new set of requirements for us. And finally, if you look at the workload profiles that are coming out of Blue Waters and Exceed and other places, you're seeing that there is this dominance of the long tail and gateway jobs. Actually, if you look at the latest report, in terms of new users, the gateway users actually crosses the more traditional command line or batch queue type of users. And that's a big change. And also you're seeing the small, and when I say small here in quotes, I mean jobs that range from a single to a few thousand cores that might traditionally fit in one rack, right? And so those jobs are really accounting for a very large, right, over 80% of our usage, right? That's a fundamental change. And then people are increasingly using cloud services as part of their science, right? Same time on the technology side, you're seeing that systems are getting much larger, and I'm not only talking about the high-end systems, but clouds infrastructure, campus infrastructure. You're seeing scales increasing, and computing and data is becoming pervasive, right? Now you have these Fiona DTNs, which have non-trivial computational capabilities in there that you can do things in the network, right? So clearly you have, at the edges, you have devices that have non-trivial computing and data capabilities. Technologies are changing quickly, whether it's networking technology as SDN or these new classes of accelerators and FPGAs that are coming out, right? Whether they are computational accelerators or data analytics accelerators or special neuromorphic chips, right? New storage technologies. Also, you're looking at new ways of delivering computing, right? Serverless computing. You had a workshop on Kubernetes and containers, right? These are truly disruptive in what they can do in the way they democratize the use and access to resources, right? And how do they become part of the software system? The capacities at the edges are growing very, very quickly, and we have to integrate and leverage them. Unconventional software stacks, again, Kubernetes, Spark, Kafka, Jupyter, right? These are not the software stacks that you typically think of in the context of HPC, right? But this is what scientists are using to do their science, and they have to be part of our vocabulary when we think about CI and software infrastructure. Networking is becoming much more capable, much more pervasive, and it has to be integrated as part of the, to connect all these pieces together. And then there are new concerns coming on in terms of precision and correctness and reproducibility and others. And they have to be part of what we're thinking about, right? I'll just go, well, so the message here is that we're living in a time of a lot of disruptive changes, and we have to evolve the way we do cyber infrastructure to realize this. And so what we've been doing is, well, let me talk a little bit about facilities because I think this is another thing that's going to drive our CI requirements, right? So a lot of the facilities, and these are large MREFC projects, these are investments of many hundreds of millions of dollars by NSF. These are large observatories, large experimental facilities, large instruments, and they are coming online and they're producing a lot of data. And a robust, dependable cyber infrastructure is critical to make sure that these large NSF investments are having an impact on the science that they are trying to enable, right? So we had a workshop recently, well, a year back now, that tried to address some of these things, right? And here are some of the findings from these things. So this was a workshop focused on the CI aspects of this, of these technologies, right? And so, of these facilities. So here are some of the findings, and I'll go through them quickly. But the key message was that because of the nature of the process and the nature at which technology has evolved and the nature at which the instrumentation has evolved, right? This cyber infrastructure is really struggling to be able to keep up with it, right? And so they needed to have a lot of investment in cyber infrastructure to connect these facilities to the users and to each other. Right now, they have no mechanisms to do on-demand data processing, to do on-demand analytics, right? Actually, it was interesting to see that even though these facilities are open, right, the modality they have to present data is to put it on their web portal, right? And downloading the data can become non-trivial. I have a lot of people telling me that, yes, it's open data, but we can't download it. It takes too long. And once we download it, we don't know where to put it and how to process it, right? And so even though we've invested so many resources in building these facilities that can really have a transformative impact on science, the cyber infrastructure has to evolve to make that impact possible. And that was a clear message from this workshop. You can look at find the report online that really outlines a lot of these things, right? And just to give another data point, there was a RFI that NSF did on CI 2030 that polled the communities to see what the nature of the cyber infrastructure in 2030 should look like. What are the driving requirements? So here are a few of these, and they reflect pretty much what the facilities report said, that there's going to be an increasing demand on computing, but this nature of that demand is going to change. It's going to be more towards on-demand streaming. Data coming in facilities and processing them is going to be very important. Clearly, there's going to be a need for data-driven science and data-enabled science, and the role of things like machine learning is going to become important. And we need to understand how to integrate that into our cyber infrastructure and to make it part of our ecosystem. How do we address the fair properties of data, making it discoverable, accessible, findable, and things like that? Reproducibility is going to be a big part of it. IoT and the edges have to be integrated in the cyber infrastructure to be able to deal with the data and to make them part of what we're trying to do. Access networks are going to be a big part of this. They need to be able to make all these components of the cyber infrastructure and the people doing the research to be able to connect them together and make them part of an integrated ecosystem. Clearly, software is a key aspect of this, and making sure the software is robust and sustainable is important. And finally, we have to sustain and nurture the workforce, which is the most critical part of the cyber infrastructure ecosystem. The responses and a summary are online, and I encourage you to look at that. And the final data point I wanted to bring out here was a recent workshop that we had at NSF focused on the future cyber infrastructure, right? And here, the report of this workshop is still being worked on, but here are some early findings that came out of that workshop, right? And the goal of that workshop was to really broaden the conversation of what the cyber infrastructure is beyond one dimension, but to bring the campuses and the cloud providers and the other resources into the room and try to collectively think about what this ecosystem should look like, right? And here are a few points. The first thing really came out of this was that there is a huge demand for capacity, right? And we should not try to bunch innovation and capacity together and deal with capacity exactly the way it should be, by providing the most capacity for the dollar, right? The other thing was to understand that we have to integrate with the instruments, with the observatories, and bring them closer into the cyber infrastructure. We need to leverage investments, whether it's in other agencies, whether it's in industry, and how do we do that most effectively? And clearly, we need to build a plan, a strategy, a roadmap that's inclusive. It's not only about hardware, it's not only about software, it's about an integrated ecosystem, a cyber infrastructure ecosystem that collectively can drive science, right? So where are we going with this, right? So this is a slide that you have seen me use, but these are the driving principles that sort of have derived through all my interactions, that sort of informing my priorities, our priorities and programs at NSF, right? The first thing is, clearly we need to think about cyber infrastructure in an integrated fashion. We cannot think about them as distinct clusters, software, hardware, HPC, but we have to think about how they come together, because that's what science needs. And I think NRP is a great example of bringing networking and data and computing together as an integrated solution. The second thing is that we need to really think about the entire continuum, right, of this translational research discipline, but think of them as separate components in this arc, right? Given the fact that we are in this disruptive time, we need a lot of innovation, right? We need a lot of new architectures, new technologies, new modalities of delivering cyber infrastructure. But at the same time, we need sustainable services that the science community can depend on to be able to do the science. And we cannot mix them together. We need to have them separate, but then we need to be able to have a transition path that takes you from this translational research onto these sustainable services. So we need to build programs that are not binned based on hardware, software, and data, but are binned along this arc. And how do we do that? And finally, right, because of the rate of change, whether it's in science, whether it is in technology, right, it's happening so quickly, we really have to couple these different cycles of innovations more quickly. We have to work more closely with the applications community, with the other directorates in everything we do, right? And we have to make them part of our programs. And we are, as I said, using these basic principles to define our programs and priorities moving forward. So the first thing we did, and I was told that this is the first time this happened, was that we built a core research program for cyber infrastructure, right? So this is where we expect a lot of the innovative translational research to happen, right? This is a place where you can explore new ideas, new architectures that are risky, right? That may not pan out, that may not lead to services that you can deploy, but they may, right? But you can try out new technologies, new architectures, new solutions, new software stacks, and try to explore them, right? So this is something, there's a webinar on this tomorrow in the afternoon, and there's a proposal deadline of 15. On November 15th, we've started small, but we want to see, what the community can do with this, right? But this will allow us to make sure that the innovation continues to happen while we can then focus on sustaining the services. The second thing we have been doing is to start rethinking how we get towards our computing ecosystem roadmap, but we also want to think about it in a more inclusive and integrated fashion, right? So this is a chart you've seen many times, right? So the first thing we did was to, the first thing that happened, and this happened before I got there, was to start addressing the leadership class, the top part of this chart, right? So we had the solicitation that came out last spring, I believe, which led to a process for a phase 1 system, and I'll talk a little more about this, and a plan for a phase 2 system. And this wanted to make sure that we had the right instruments for the science that needed that scale, that extreme scale, right, of leadership class, and make sure that we had a path that's both sustainable, that gets some amount of continuity, but at the same time can be innovative, right? And that's why we did this phase 1, where we did a system that ensures continuity in phase 1 and a phase 2 system that can then look at the future needs and future technology and can be more innovative. Then we did was to buy us some time, in essence, right, to be able to start understanding how to look forward. So we have extended the timeline, and you can see those in those dashed lines, of our current ecosystem, our current resources, what has been called the innovative HPC, right? The data intensive, the cloud, and the other platforms that we have, but also the open science grid, which is a federated system that provides a huge set of resources for our community. And then we have been continuing the effort of understanding what the community needs and how do we work with the community to start to defining what the future CI roadmap should look like. And this ended in this workshop in May that I talked about that gave us a lot of insights. And let me tell you a little bit of what our thinking is right now, right? So we're sort of looking at investments around at least these few quadrants, right? The first one is leadership class. And as I mentioned, we are well along this path, right? We have a solicitation, and many of you must have seen this NSB resolution that authorizes the director to make an award for the phase 1 of the leadership class system, right? And as time progresses, you'll hear more about this, right? So this makes sure that now we have a path forward to these extreme applications. We have a resource that meets the leadership class needs, and we have a path forward to evolve that into a phase 2 system under the leadership of TAC. So what are the other quadrants of here, right? So second thing, we need to understand that we have a huge demand for capacity. So we are looking to see how do we meet this capacity in an innovative fashion, right? So in the past, we have had this innovative HPC program that asked you to come up with new architectures, new methods, but at the same time, deliver capacity on day 1. And that sort of doesn't mesh together. The communities aren't ready. Technology is new, right? So we said, okay, let's try to call capacity exactly that. How can we provide it the maximum capacity for the resources that you have, right, or for the dollar that you have, right? It's innovative, and here innovative means how do I come up with new ways of providing the capacity? For example, maybe you can use a federated model that leverages campus investments. Maybe you can have a cloud backend that provides capacity by federating or by using cloud services, right? So while here it's not the innovation in the architecture necessarily, but innovation in the way you bring resources together to maximize the capacity, right? And how do you do that in new ways? Federated resources are a big part of it, and we need to address that they have to come together collectively, both from providing this capacity, but also integrating different capabilities, the instruments, the diverse user needs, right? How do you, and different communities, how do you make sure that these are not done as an afterfact, but they're an integral part of our ecosystem, right? We need to still have innovation in architectures, so we're looking at exploratory pilots as a way of being able to have this innovation where the expectation is not that you are production ready on day one, but the expectation is that there is a pathway to get this to production, right? But you have time to build up the community, to try out your innovative solution, to be able to understand what its requirements and what its capabilities are, right? So we want to make sure the expectations are right, but still enable innovation. And finally, it is essential that we invest in and leverage cloud services and campus CI. I think campus CI is the backbone of anything that we do, and we have to come up with the carrots that we need, the incentive mechanisms to grow and integrate the campuses in there, right? And how do we leverage cloud services? And these are, you'll see actions in these areas in the very near future, right? How we do this. And finally, we do need the coordination, the management, the allocation services that completes this pathway, right? How am I doing for time, Larry? Okay, I'll do this quickly. I wanted to say a few words on HDR because that's the next opportunity coming for this community, and I think this community can play a big role. So right now, we are thinking of a HDR framework that really has at its core CI investments, whether it is the cyber infrastructure, where it's knowledge networks, whether it's model and data commons, right? So that is at the core of HDR. And then we have these activities that translate these to different domains. So you have domain-specific HDR satellites that evolve around these. And these could be institutes, these could be projects, right? So the blue on top of them are these domain-specific that are addressing specific problems, right? But then you have the core that's addressing the infrastructure aspects of the common cross-cutting infrastructure that's common across the different aspects of HDR. From a programmatic perspective, you're looking at least 3 key components, right? The first one is looking at research, and this includes theoretical foundations that look at math and machine learning and statistics and other aspects. Systems foundation, whether it's algorithms, whether it's system architectures, whether it is things like knowledge networks and model commons. And then there is the research that combines this and translates it to domains. We're looking at educational pathways, right? How do we build the workforce? How do we make sure that we're investing in the educational activities? And then the core cyber infrastructure that's essential for this, right? And there are some activities that you might already seen in these areas, but there's more that's going to be happening here. I wanted to highlight a little bit on the cyber infrastructure, and I like to use this here as cyber infrastructure continuum, because the idea here is that if you look at this core, it has to span from the edges, from the campuses, from the instruments to where our large computing facilities is and having everything in between, right? The network elements, the data transfer nodes, it all has to be part of the cyber infrastructure, right? So we need to be able to create an infrastructure that's integrative and connects these pieces together. It's also important to have a backbone, right, in which these different investments, whether it's at campuses, whether it is at these centers or at these domain-specific observatories, plug in and then are part of this whole, right? And you can create a whole that is much larger than the sum of the part, right? And how can you have the expertise that goes out of it? And if you start thinking about it more holistically, there are many science drivers that are coming out of it, and that's why the different directorates are very, very excited about this, right? So I wanted to close with one example that I'm familiar with, and it really leverages investments out here by this community. So this is a thing that really some of the folks over at Rutgers have put together. So just to give you a story, there were some earthquakes off the coast of Alaska last, I think it was December. And we were talking at a meeting with some of these facilities and said it'd be great if you could look at it from different modalities, right? So we have IRIS that is looking at the seismic, there's OI that's looking at different ways, right? There's the hydrophones, there's also the other observatories there, and then you have UNAFCO that has geodesic data that's coming in, right? And so we said, let's try to put these together, and we quickly found that it was really non-trivial. It would take months for a postdoc to even integrate the data, right? And so we said, let's try to see what we could do. So we had just started, well, not started, we have been working under the leadership of Ivan Rodero, the VDC project, the Virtual Data Collaboratory at Rutgers, and we were leveraging some of the outcomes of the PRP, right? So we said, okay, let's put these PRPs and use that as a way to stream data in, to triage the data, and to detect events of interest, and then launch workflows on the streaming data. And so we have a demo, and there's a paper on this as well, which is leveraging this and can do this sort of early warning in near real time based on doing in-network processing of this data, right? And this is just one example of when you put all these things together, the transformative effect that can come out of it, right? I'm running out of time. I just wanted to end with some personal observations, given that it's 6 months. But I think the key thing out here is that we are at this inflection point, right, where cyber infrastructure is getting tremendously capable, right, in terms of this, what industry is doing, what NSF is doing, what the research community is doing. At the same time, application requirements are evolving where they see that need for this cyber infrastructure, and this can have an immediate impact on their science. So I think it's the right time for bringing these communities together and for me to understand where incentive investment from NSF can really have a value to catalyze a lot of these changes. With that, I'm going to stop and say thank you. I think science is depending on an integrated cyber infrastructure. It's critical to the way science is being done, and I think this community is the right community to address many of the challenges. Let's work together and build that cyber infrastructure ecosystem that can transform science. Thank you. I'll stop with this slide. I don't know if I have any time for questions.